Okay, this lesson is on section 2.1, or yeah, 2.1, and it's about lines. Enjoy this while it lasts. You've learned a long time ago the slope-intercept form. Okay? IB, why uses, a more international version of this. Why we can't all use the same words. It's probably our fault as Americans, but they call it the gradient intercept. And really, it's the same thing, but you will probably see it as mx plus c, where c is the y-intercept and m is the gradient. Gradient is the same thing as slope. Gradient is used in a lot of things outside of math, though, like road. You'll see the grade of a road coming down Teton Pass says 10% grade. Um, that's probably one of the biggest examples. You'll see a lot of places that are 6% grade. That means the gradient. A slope of 6 as a percent, 6 over 100. So it drops 6 feet every 100 feet, or 10% gradient, 10 feet every 100 feet. That's a slope. There's the point slope, which is y minus y1 being any y coordinate. So these have a corresponding point at x1, y1. And there is standard or general. This book is going to call it general. I think I've seen both. Usually, if they want it in this form on the test, they'll just show you the form. And you may have seen it as ax plus by equals c. It doesn't matter if those are capital. You'll probably mostly at this point see it like this, where they move the c to the other side. Yes, that switches the sign on the c. It's fine. You just give the values that are there. A, B, and C, though, must also be integers. Okay, that's one of the key things to standard or general form. Okay, let's do a couple examples. This will be a short lesson because it's lines. So here, a straight line is given in this form. Give the coordinate of the y-intercept. Well, the y-intercept, so let's just put it in slope-intercept form or gradient-intercept form because I'm going to need the slope anyways. For the x-intercept, I'm just going to plug in the y-coordinate of an x-intercept is 0. So I'll do that. So I'll subtract 4 from each side to get to this. 3 times 0 just goes away. Subtract the 4. The x-intercept, then I'll divide by 15 on both sides. The x-intercept is x equals negative 4/15. To put it in gradient intercept form, I can get the y-intercept out of this. 15x minus 3y equals negative 4, so I'll subtract 4 from both sides. I'll then subtract 15x. Maybe could have just done both of those in the first step. And divide everything by negative 3. giving me y equals 5x minus 4/3. I could have plugged in 0 for x to get the y-intercept as well. I just figured since I had to convert, I might as well do both together. Um, oh, it did ask me for the coordinates. Really important to actually read what it asks for. Oh, it's a positive. And not miss the fact that negative over a negative is a positive. That should be a plus 4/3. So I have to be careful. Um, the x-intercept should also be given as a coordinate and the gradient as 5. So all I can say is be extra careful to give what they're asking for. Okay, so show this in general form. So notice they specifically asked the form they wanted it. So I'm going to start by finding the slope using the old slope formula, y2 minus y1 over x2 minus x1. Again, the most important part about the slope formula, well, A, that y's go on top and x's on the bottom, and that these two things are from the same coordinate. Okay, so now we'll just solve that. -4 minus 1 is -5 over +5 equals -1. I'm going to use the point slope form. Y minus, I'm going to pick the first point because the numbers are smaller. It's not really particularly important which point you pick, but I like to use smallest numbers I can. Y minus 1 equals -x minus 2. I need to set it equal to 0, so I will add x and 2 to both sides and get x plus y plus 1 equals 0. They found the y-intercept and went that way. I prefer to use this point slope form. I think it's slightly faster, but really doesn't matter. If you look, they plugged in for x and y and solved for c and then used that equation. Okay, parallel and perpendicular lines. Okay, we know from previous experience that parallel lines have equal slope. So if the slopes are the same, so it's helpful to be in one of the slope forms, either point slope or slope intercept. Um, for either of these. It's also helpful, so here they've got, this nicely notated with the parallel symbol between L1 and L2. Usually we'll do L's should be cursive. They have a nice typed one that looks different than a 1, so that's fine. Um, this little symbol, it's important to note that it's an if and only if symbol. So L is parallel to L1 is parallel to L2 if and only if M1 is equal to M2. What does that mean? It means it goes both ways. Works backwards. I can say M1 is equal to M2 if and only if L1 is parallel to L2. Works both ways. It's true. Either one can be the if clause and the other one's the then. Okay. For my conditional statement. Perpendicular lines. We know the slopes are opposite reciprocals. So a good example is right here. Often that's notated as they multiply to -1. 3/4 times -4/3 definitely equals -1. We can cross cancel everything. And remember, when we cancel with multiplication division, they become ones, not zeros. Okay, so let's take a look at a couple examples on this. So write in general form the line parallel to this that passes through that. Parallel to 2x plus y minus 6 equals 0 that passes through 2, -6. So first thing I need to do is find the slope on this. We'll do those to both sides. So I know my slope has to be -2. Now I take that and my point, y plus 6 equals -2, x minus 2. Now I'm in point slope or slope point gradient, and I just need to change forms to general. I'll move everything to the left side. And I get an answer of 2x plus y plus 2 equals 0. And that's in the form they want. This is a pretty common thing that they will want this in higher level maths. Okay. AP often asks for stuff in that form too, with the equals 0. It's a little different than earlier, but that's fine. So the next one asks me for the line perpendicular. Similar idea, but first thing I'm going to do is convert to slope intercept to get the slope. It's always easier to go to slope intercept than point slope, so giving me so now I'll do the point slope with my point. I must do opposite reciprocal. That's got to be positive. Positive 2/3. And now it doesn't specify the form. That's correct. It may want me to convert, but it doesn't specify, so that's actually correct. Oh yeah, they didn't bother converting. Yeah, I would stop there if it doesn't specify. I thought it was going to ask me to convert to general, but it doesn't. Okay, we're going to skip a few examples because it's kind of more of the same thing, and it's lines, so you should know how to do this. So find the value of k if these two lines are parallel, and then if they're perpendicular. So First thing I'm going to do is convert to slope-intercept form. And doing that to both sides. So yes, it's that. And then I'll divide by 4. Now let's do the same thing to the other one. Okay, so if they're parallel, my slopes have to be equal, which means -1/2 has to equal k over 3. I solve for k by multiplying both sides by 3, and I get -3 over 2 equals k. If they're perpendicular, we'll do perpendicular in red. I need them to be opposite reciprocals. So positive 2 over 1, k equals 6. So aligning them into a form with a slope, and this, you just have to set the slopes to what they need to be. And that is our little lesson on lines.